In this episode, I'm going to show you how I installed a 7-way trailer towing harness in my camper trailer. Welcome back to this ongoing series on the renovation of my 1949 Spartan Manor camper trailer. I just want to point out that this is one of 2 electrical systems that will be installed in the trailer. This is a DC voltage system used only while the trailer is being towed, and so it's like the brake lights and things like that. The other system will be the regular 110 volt domestic system that you have in your house with circuit breakers to power the lights and the stove and everything else. In looking online, I saw several different ways of wiring trailers. There was 4, 5, 6, and 7-way trailer wiring systems. And those numbers simply refer to the number of wires involved, whether it be 4 or 7. In looking at home improvement and auto shops, I saw they typically had 4-way and 7-way connector systems. The 4-way trailer wiring system appears to be for smaller trailers that just have brake lights and turn signals, whereas the 7-way trailer wiring system appears to be for larger trailers that may also have reverse lights, electric brakes, and auxiliary power needs. I decided to go with the 7-way because my trailer has electric brakes and the taillights I selected have reverse lights in them. My next decision was that I would only run cables through the chassis rather than individual wires, and anytime I need to make connections, I would install a junction box. Before we go over the build, I thought it'd be handy to get an overview of what I ended up installing. Here up at the front is a 7-way trailer connector with a 16-foot cable running into the trailer. The cable runs along the chassis to this first junction box, where it then goes to 2 additional junction boxes for the brakes. From there, a 2-conductor cable runs forward again to this junction box that goes to the side markers. From here, it also runs back to this junction box where it goes up to the tail lights and the side markers. With all that covered, let's get to the build. The first step I took in making my towing wiring system was to replace the tail lights. These did have some kind of a little gasket on the back. It's not very round. That looks so good already. These are one of the first things I bought. There were some holes around the taillights from previous taillight installations, and I dealt with that by putting in some buck rivets. That one's looking good. Before cutting gaskets out of the silicone sheet, I thought it'd be a good idea to make some out of paper to make sure I was getting the right dimensions. With the size verified, I then felt confident cutting into the silicone sheet. I have some number 8 by 3/4 inch stainless steel screws. I have a 3/32 of an inch drill bit, and that should be good because you can still see the threads on either side of it. Now, I haven't made holes in the gasket. I was able to just poke through it. That's very satisfying. Now I need to decide where to put these, and originally they were way up here. You can see by the holes. And I don't know if I like that look up there. That, to me, it looks a little silly. I kind of think it'd be cool to keep it on the same level as the lights. Maybe just have it here on a nice flat spot. And that's about where it was before. So that's at about the height of the brake lights. Okay, there's down lower. And that's the more original position, which looks out of place to me. So this will be the lower position up front, which I'm favoring right now. The lower position was my favorite, so I measured out the location of each marker light, drilled holes for the wires, and holes for the screws. The marker light gaskets were easier because all I had to do was trace the outside and punch holes for the wires to go through. Then fed the wires through, screwed it in, and put on the cover. There we go. I'm not entirely sold on the silicone gasket yet. I feel like it would need a few more screws to pull it in tightly. So I might end up taking that off and just using some kind of caulking. Here are the other marker lights going in. Looks great. And of course on this side I forgot about this giant hole from a vent of some kind. And if I wanted to be 3 inches down from the rivet line like on the other side, that would be right there. So it looks like I will have to complete a patch first before I can put on that blinker. I finally decided to test the brakes today, And I have these wires connected to a 12-volt battery. You can see the wheel hub spins pretty freely right now. Once I connect the wires to the terminals here of the electric brakes, you can see that this becomes much harder to turn. So it works. This is the 7-way trailer cable that I bought with a junction box. So here the wire comes in, and it does look like these are different gauge, so the brake wires are thick. As you'll see in tables like this one, the different parts of the trailer require different wire sizes depending on how much power they need. So the brakes have rather large wires, whereas the lights have smaller wires. And all these numbers are on the AWG scale. In case you're not familiar, AWG stands for American Wire Gauge, which is a standard for the diameter of the conductor and thus its current carrying capability. Perhaps counterintuitively, a higher wire gauge means a smaller wire, and a lower wire gauge means a larger wire. As an example, here is an 18 gauge wire, and here is a 10 gauge wire. All right, the first thing I need to figure out here is how to place this cable. And I've read that you generally want about 2 feet of cable sticking past here so that you can attach it wherever you need to on the vehicle that's towing it, and then figure out how to route it underneath here. All right, the first thing I want to do is mark off 2 feet on this cable. And I could run it through here, but then I think I would have the problem of where to put this when it's not being used. And so I'm thinking that I would actually like it so that I could tuck it all completely underneath when it's not being used, because this thing is going to be sitting, not being towed most of the time. Here I'm taping it to the trailer tongue just to make sure I don't pull too much of it through. So we want to thread this cable through the chassis, and there are even these metal clips to help hold it in. Before I could thread the 7-way cable through the chassis, I had to remove this beautiful junction box that came with it. There we go, now we have this free and we can thread it through the chassis. So after running through the chassis, we've arrived to right here. Now that we have the cable threaded through the chassis, we can put the wiring back in. Even though it would make for some extra length up in front, I think I might have it so that the box just goes right here. Here's some more trailer cable to do the tail lights and turn signals, which it seems like in most trailers and trucks, the brake light acts as the blinker as well. I prefer to have the blinkers be their own lights, but that looks like it takes another attachment to do, so I'm going to run this back from here. I bought this 4-way trailer cable because I was trying to stick to the color code, but really I need a 5-conductor cable to go back because I have reverse lights. And you'll see that I use an additional 2-conductor cable to make up for that. Anywhere I needed to make wire connections, I put a junction box similar to this one. And for every cable going into it, I installed a cable gland. Let's take a closer look at one of these. These are cable glands. I think they're also called strain relief. And inside here, you can see that there are 2 different pieces that help cinch down on the cable. There we go. So that nests in there, and then that goes in there, and then that nut tightens down on there and pinches this together to hold the cable securely so that no strain is put on the connections inside the box. And so if you're unable to just push this through all in one go, you might need to take this apart and assemble it piecemeal here. There we go. Then you can put it through, push as much wire through as you need, so much cable, and then you can cinch that down. See, and then that's not going anywhere. You can pull as hard as you want, and that's going to stay right there. It's actually much easier to remove the sheathing of the cable before you put it in the box. So I'm just going to remove several inches here. I bought some hardware to help hold the box to the chassis. So I'll drill a hole and put those screws through, and have a washer and a nut, and some lock washers. I'm just gonna put that through. You can see there are some burrs on the backside from drilling it out, and I'm just gonna use this bigger drill bit and get rid of those burrs. All right, we have 2 screws holding that nice and firm to the chassis. Now we'll pull any slack out of that we don't need. I'm gonna cut it to here just in case for now. Rather have too much than too little. From here we need to go to the brake lights, and I might have both cables go up here, run along the inside of that channel, and come in here. One will go there, and one will go to that light. You can see here I wasn't careful enough, and I've actually nicked the inner insulation. So I'm just gonna start over. And I believe all this talcum powder is there so that when you do remove this casing, the outer insulation, that it'll slide off. Now we just need to figure out how much length we need to run up to the first brake light. I'm gonna cut it here, and there'll be plenty of length to join to those. Now I'm running the second tail light cable. And you can see I've made it so that the cables come in and the insulation ends right about where the hole ends. That way you have all this flexible end to work with. Here I'm measuring out the length of the cable for the second tail light. That's not an ideal pass-through because it's just the cable sitting on bare metal. So I picked up some rubber grommets to pad the holes. And they need a 1/2-inch drill bit. There's the grommet installed. Uh-oh. So I found that putting a little bit of spit or water on the grommet before putting the wire through really helped it slide through, and now it's in. To get the signal to the reverse lights, I have this 2-conductor cable. So let's just start running it through. And the last little pass. And yeah, we still have plenty to work with in here. For joining the wires up in here, I got these little Wago connectors. So you can open them up like that, put the wire in, close it, and that'll connect 3 wires together. I thought that would be a convenient way to do it in case I had to undo anything. The instructions for these say to snip off 11 millimeters of the insulation from the wires that you're going to connect. We have our running tail light wires connected. All right, this box should be all connected, hopefully correctly. The color codes really don't mean too much anymore. I just need to keep track of what color wire goes to what function on these lights and make sure I connect it correctly on the box over there. I have a bunch of small wire nuts to temporarily wire these together, and this is just for the test. For the back marker lights, I'm just going to have a cable go across here and join up here at the brake lights. We'll put another grommet and pass this cable through. On this side, there's already a grommeted hole going through, so we can come down like that, and we'll just loop over across to that one. Again, I'm just using wire nuts to temporarily connect all these wires to make sure it works before I solder them together. Now I need to drill a hole just the right size for this cable to pass through here, and this other one for this cable to pass through. Yes, there we go. And that's the ticket. So I got this little box of crimp connectors. So after a bunch of cutting and crimping, you can see I have the 4-conductor and 2-conductor cables joined up inside this first junction box. Oh, so you got the thing. To power the forward marker lights or clearance lights, I'm running another 2-conductor cable from the first junction box to another junction box up forward. And then it's going to go to the one on the left side and then the one on the right side. There's our little junction box for the forward marker lights. Up here, I just have to work on a little cable management. For doing that, I've got more of these steel insulated clamps. So I have another stainless steel screw, and I'm putting a washer on the back and a nylock lock nut. I ran it along here as well, and I'm waiting to repair this and do the floor before I solder the wires together. I bought a couple of these 5-hole junction boxes and a bunch of larger wire glands so I can wire up the brakes today. This first box I'm going to put right here, and then the second box we'll put over here. There's our box, and it's going to get fed directly from that one. So this little gland, if you can call it that, needs to have a hole in it big enough for this wire. Perfect. And it's going to go inside like that. This would be a ground wire, normal 110 volt wiring, and we're not going to use that. I couldn't find a 2-conductor 12 gauge cable at the store, and that's why I cut off that extra wire. Here's the brake cable coming from the junction box. I might do it like that. I mean, although of course it's neater going like this, but one of them is going to have to cross back over. Here's the cable coming from the back left brake. Even though this cable is thicker than the others, with the larger cable glands, I'm able to slide it right through. And I think for the other brake, I'm just going to have it go like this and go down in there. I think that's pretty neat. And then this one will have the cable going to the right brakes. Now we'll connect all the wires with these Wago connectors and close up the box. And then of course it's much the same procedure for the junction box for the right side brakes. Boom. I bought these little cable clamps to help support the brake cables going across the chassis here. Have some more stainless steel screws. These were 70 cents each. It makes me feel so old. Alright, another box we can close up. I don't want the inside of this cable being exposed to the elements, so I'm going to try and seal it up with some marine heat shrink. And this should theoretically make it waterproof because there's a glue in here that melts. That looks a lot better. You can see the glue melting up and oozing out on the edge there, which is a good sign. Now I'm putting on the crimp connectors. You can see it has the nice indentation in there. And the little arms of it have folded over nicely. And that's not coming off. And of course I repeated this for the 3 other brakes. Was anybody else bothered by the fact that I drilled all these holes in this newly painted chassis and didn't paint them? Me too. Although it was annoying to go unscrew everything, I felt a lot better putting some primer and paint on these holes so that it won't be rusting years down the line. I am ready to test things out today, so I'm going to tighten up all these. And finally, we can close up the main junction box. For these metal tabs, I'm going to use a soft face mallet to bend them over a bit more. I have these wires hooked up to the battery so I can test the lights on the trailer wiring system. So looking at it like this one is ground. Let's try up here, which should be running lights. We can go check that. Very faintly. Very faintly. There we go. Brake lights. Brake lights there. And running lights there. And a quick check of the reverse lights. Our lighting test was successful, and now I'll make these connections more permanent. Here's my little soldering station. I have my soldering iron with a damp sponge, solder, I have wire strips, I have side cutters, heat shrink, and of course the heat gun. Okay, let's tackle a set of 3. These are the ground wires. I'm gonna start off twisting these 2 together to get it going. And before you solder them together, you wanna make sure you put on your heat shrink, or else you're not gonna get that on afterwards. Sometimes it's good to get a little bit of solder on the iron itself. And that helps it get flowing into the wires. Before joining the wires up, I like to get a good amount of solder on each one. Then I can hold them together and simply heat it up. You'll probably see and feel when it cools enough to solidify. Then slide the heat shrink so it's centered over your soldering work. Then use the heat gun to make it shrink around the wires. And at the edges of the black heat shrink, you can see that clear glue coming out, which means it's making a nice waterproof seal. So here's one tail light, all wired in. Then I repeated the process anywhere I had wire nuts. Now I'm going to hook up the truck to the trailer and test what lights I can. This is the plug coming from the trailer, and then this is the adapter for my truck. The truck only has a 4-pin connector, and the trailer has a 7-pin. So this allows us to connect it, but of course we don't get all the functionality out of it. We don't get the reverse lights, we don't get actual brakes. Okay, can you turn on the lights? Can you turn on that left blinker? There we go. It's not a huge difference in brightness. Yeah, turn off the lights. And then blinker. Yes, that looks fantastic. Can you do the right blinker?
Yes!
Alright, can you put on the hazards?
Yes, that is so satisfying. If you've made it this far, thank you so much for watching. It was a lot of work to do that, and it was a lot of work to make this video, so I hope it's been useful to some of you. Overall, this part of the project cost about $450 and took about 18 hours, not counting the multiple trips to the hardware stores I had to make. Thanks for watching, and see you next time.